Hi, welcome to our next level 3 integration video. In this video, we're going to talk about a topic we brought up in differentiation, a topic about kinematics. Kinematics is the study of motion, and we use the following notation in kinematics. S is displacement, which is a fancy word for distance. V is velocity, which is a fancy word for speed. A equals acceleration, and T is equal to time. Now, we came across this chart in the differentiation video. To take a displacement formula, we differentiate it and turn it into a velocity formula. To take a velocity formula, we differentiate it and turn it into an acceleration formula. And therefore, working backwards, we anti-differentiate or integrate to go back to a velocity function or a displacement function. It's also important to know that direction is important. So if things are going up, we take it as positive. If they're going down, we take them as negative. If things are moving to the right, we say it's positive. And if things are moving to the left, we say it's negative. All right, let's get into our example and show you how we use kinematics for integration. The velocity of a rocket in meters per second, which is fired vertically from a launch pad that is 5 meters above the ground, is given by the following formula. Vt, velocity, is equal to 0.00096 times e to the power of 1.2 times t plus 1. We need to determine the height of the rocket after 15 seconds. Right, well, the rocket's traveling upwards, so it's positive. So our velocity is positive, our distance is positive. All right, here's our chart. And because we've been given a velocity function, we need to integrate or anti-differentiate it back to get a displacement distance formula to work out the height. So here is what we're going to do. We're going to work out the displacement function by integrating the velocity function with respect to t. Right, so E integrates to itself, so 0.00096 E times 1.2 t plus 1 will integrate to 0.00096 E times 1.2 t plus 1, but we must divide it all by the 1.2, which is our composite function. That's the derivative of u dash. And we must plus on some constant c. Now, if we tidy this up and work out what 0.00096 divided by 1.2 is, that gives us 0.0008. So we've come up with a displacement or distance formula, which is 0.0008 times e to the power of 1.2 t plus 1 plus our constant c. Right, we were told that the rocket was launched 5 meters above ground, so we're going to put that in for our distance at time of 0. So we're going to work this out, grab our calculator and work out what 0.0008 times e to the power of 1.2 times 0 plus 1 is, and that gives us 0.002175. So we have 5 is equal to 0.002175 plus c. When I subtract the 0.002175 from 5, we get a c value of 4.998. Some of you might choose to round that to 5. It's pretty damn close to 5. I'm going to be a little accurate and keep it at 4.998 for now. Right, so this is our distance formula. We've worked out c is 4.998. So the question says, what is the height of the rocket after 15 seconds? So all we now need to do is substitute 15 in for time and work out what is 0.0008 times e to the power of 1.2 times 15 plus 1 plus the 4.998. And that gives me on a calculator 142,785, and if I divided that by 1,000 to turn it into kilometers, I'd round it to something like 142.8 kilometers. Great, thanks for watching.